Good day. In this video, I will show you how to run short circuit analysis using ETAP software. So first, click on the short circuit button located at the system toolbar. Select the network configuration located at the 3D database toolbar. Make sure that it is under the normal condition. So we can notice that different buttons are now on the right side of our screen that we can use in running the short circuit analysis. But in this case, we will just use the run three-phase device duty. So click it. After clicking it, a prompt will appear which will need your output file name. For example, mine will be SC, a short term for short circuit. Then click OK. And now we can notice that from prompt it become SC, which is your output file name. So now we can see in our one line diagram or in our OLV that the different buses has already run the short circuit analysis. Uh, the results can be seen OLV. Notice that both the high voltage circuit breaker and the low voltage circuit breaker turn red. So that means that this has error in our circuit or the breakers are in critical condition. So to check the errors or the problems, click the alert view on the side. And check what is needed to be adjusted. So in here we can see that there are a lot of breakers needed to be added as we have too many errors. So we can see that B1 is under the interrupting condition as the percent operating of the said breaker is already 115 as it should be only 100%, and the operating value of it is 72.475 ampere kiloampere, and our rating is below that, which is only 63 kiloamps. So for this to be solved, should go to the bot edit tab, edit button, and edit the rating of the breaker that is said to be faulted. So to edit the values that is needed, the problem for B1 is the interrupting and the C and L RMS, which is under marginal. So interrupting and C and L RMS. So to edit the interrupting value, we can't just enter any value that we like. It has to be proven and have a proper formula and assigned value. So to solve the interrupting issues of high voltage circuit breakers, the solution is as follows. So we will manually compute the values that we will input in the ETAP. So set the operating value as equivalent to rated short circuit interrupting capability. So we can notice that the problem of B1 is it has 72.48 kiloampere for operating but only have 63 for rating. So setting the operating value 72.48 as our new rated interrupting capability. So from there, we can solve the new maximum interrupting capability, which has the formula of the product of rated interrupting capability multiplied by maximum kilovolts over the kilovolts rating. So we can see in this table that the power grid or the B1 that we are solving has a kilovolt rating of 13.8, a max kilovolts of 15, and a new rated interrupting capability which is 72.475. So now computing this, we will now have a new value for our maximum interrupting capability, which is the 78.78 kiloamps. So changing this rated interrupting capability to what? 72.48. 72.48. And our new max interrupting capability, that is 78.78. So click OK. Then go to the short circuit analysis again. Run the three-phase device duty. Now we can notice that the only problem for B1 or the breaker 1 is the marginal. So click the alert view to see what is the other problem of the breaker, and it is the C&L RMS that as a under the marginal condition, as it is close to the value that we set for the marginal, which is 95.6. So to solve this issue, we should manually compute the new value of the C&L RMS. So to compute this, we have the formula of C&L RMS, which is 1.6 multiplied by the maximum interrupting capability. So 1.6 multiplied by the 78.78, which is the value that we solved earlier, and the answer will be 126.04. So, to avoid further issues, we should also solve for the C&L peak because the maximum interrupting capability already changed, to make sure that the breaker won't have any error again. We should also solve for the C&L peak. So, the formula for the C&L peak is 2.7 multiplied by maximum interrupting capability, which is again 78.78. Now we will have a new value for C&L peak, which is 212.70. So we should put this in our breaker ratings. So we have the rating for the C&L RMS, that is 126.704, and for the C&L peak we will have 212.7. So click OK to save the values. Then go back to the short circuit analysis and run the duty check. So we can now notice that it is neither red or magenta, which means that this breaker doesn't have any errors. So double checking in the alert view. Searching for B1, and we can be sure that B1 is already solved. So to solve the issues of the other breakers, just repeat the process and solve manually for the new rating of the error breakers. Now for the low voltage circuit breaker, checking what is the error, we can see that the low voltage circuit breaker is under the critical condition as it is interrupting. Its percent operating is too high, that we should adjust its rating from 42 to 132.025. So checking what's in the interrupting kiloampere of the breaker of the low voltage breaker B13. So we can just click on the drop down button of this breaker. We can say that 200 kiloampere will be fitted as we only need 132 kiloampere for it to meet the requirement of its operational kiloampere. So click OK. Then check if it will have any error. And now we can see it is already solved. So again, checking what is in the alert view, we can see that these operating values are all fitted under the 200 kiloampere that we can see in the drop down of the circuit breaker of low voltage. So change this to 200. And now checking, we should run the device duty check again. And we can see that all the problems in the breaker under normal condition is now solved.